Okay, example 3 here. All right, so again, pretty much the theme of this lesson is going to be given some type of quadrilateral, classify it. So example 3, as you can see, we've structured it so it's the same layout to get you an idea of you need to find links and you need to find slopes and then interpret what those links and slope then mean. So letter A, again, if this wasn't saying just letter A, I just said classify it, then we would go ahead and start off by finding links, and then we'll be going through and finding slopes. So as I'm talking here, go ahead and do that. Start finding your links, start finding your slopes here. So let's go ahead and do that on the next one. It looks like it's a parallelogram. That's usually what a lot of students say, but we're not sure about that yet. So let's go ahead and find this here. So AB. I'm going to go ahead and use my graph. I can, because this is going up 1, and this is going over 1, 2, 3, 4. So finding the length there, I went up 1 and over 4, so that's a 1 squared plus 4 squared. That's the square root of 17. While I'm doing that, I can go ahead and just find the slope at the same time. The length of AB is, the slope of AB is up 1 over 4. It's increasing, so it's a positive 1/4. BC. All right, I'm gonna just go drop it down and over. I dropped it down 1, 2, 3, 4, 5, 6, 7. And I went over 1, 2. Now, 7 squared plus 2 squared is 49 plus 4, which is the square root of 53. Simplify it if you can. You cannot. And I went down 7, so that's a negative 7 over 2, and I ran 2. Okay, next one here. Find all the sides. So on this one, I'm going to go down 1 and over 4, it looks like. Square root of 17 again. Now, down 1 over negative 4, that's a positive 1/4 for the slope. And then lastly, for AD, DA, down and over, 1, 2, 3, 4, 5, 6, 7, run 2. And because I went down 7 and right 2, it's a negative 7/2. And in terms of Pythagorean theorem, to find that length, or using your distance formula, anything that you want to do there, I don't care. Just make sure you get the square root of 53, okay? Now that I have that, okay, based off these sides, if I just looked at the side lengths, well, I would say I have either a parallelogram, which a lot of people say, or it could also be a rectangle. So what tells me the difference between those two is, do I have right angles appearing? And now that's what I'm using for the slopes. The slopes will tell me that. Okay, this slope was 1/4, and this slope was negative 7/2. Okay, because of that, 1/4 and negative 7/2 is not the opposite reciprocals. Okay, opposite reciprocals means it's 1/4, the other one should be negative 4. Or if it's negative 7/2, the other one should be 2/7. And because I don't have that, yeah, we've got ourselves again a parallelogram. If it was a right angle, then I would have, like I said, opposite reciprocals, 1/4 and negative 4. And I don't have that. These are not opposite reciprocals. So I have some students say parallelogram. I had some students say rectangle typically in class, but this is officially a parallelogram. So the shape is a parallelogram because two pairs of opposite sides congruent. So that takes care of talking about my side lengths, but that alone is not enough to tell me it's just a parallelogram. How could I know it's not a rectangle? So then, and adjacent sides are not perpendicular because these slopes, I should say the adjacent slopes are not opposite reciprocals. If I could write today. Okay. Now the perimeter of this one, we are going to do is add up all the sides, okay? I have two sides that are root 17. I have two sides that are square root 53. So 2 root 17 plus 2 root 53. Best I can do. Because this is not a rectangle, it's a parallelogram, I would have to go through and find the length and the perpendicular height, and I'm not going to worry about